Here's one of the most overlooked soil amendments that can have a direct increase on root growth. So obviously, as soon as we put the seed in the ground, we want to make sure that environment is absolutely perfect for emergence to get that thing off to a good start. In this video, I'm going to briefly discuss about how humic acid can be a part of that equation, what it is, where it comes from, and what it can do for us. So humic acid is everything that we know and love about organic matter except in liquid form. It's the final product of the degradation of organic matter. So we start with residue, with trash out in the field. It gets broken down into organic matter. The microbes continue to decompose it into humus. And then from humus, then we get humic acids and fulvic acids and humates. And for this video, we're just going to be focusing in on humic acid. But the big difference between humic and fulvics is humic acids are just larger, fulvics are more soluble in water, and what have you. So, with that being said, everything that we love about organic matter and what it does for us is what humic acid will do for us. So, there's going to be multiple different ways that it changes physical properties of the soil, chemical properties of the soil, along with it being a food source for microbes. So, we'll start there. It's got soluble carbon, which is the food source for microbes to deliver us more nutrients, to make nutrients more available to us for the crop to utilize. As we're feeding those microbes, the microbes are also going to be increasing organic matter, which will give us better water holding capacity, better aeration and porosity, which will lead to better drainage. And any soil, all healthy soils are able to do all three of those things: hold water, hold nutrients, drain water, and be able to breathe. So it has a big impact on the physical properties of the soil, along with the chemical properties of the soil. So with humic acid, it's going to increase the cation exchange capacity of the soil, or the CEC. It's the soil's ability to hold cations. Cations are your positively charged ions that are in the soil. So when you think of cations, think potassium for sure, calcium, magnesium, iron. It's the soil's ability to hold onto those, because organic matter and clay are negatively charged. The soil's got a negative charge, so those exchange sites are going to hold positively charged ions. So the CEC is the soil's ability to hold them and to exchange them to the plant. So humic acid will increase the soil's CEC, thus being able to hold more cations, more nutrients for the plant. So one way we applied humic acid last year was 1 quart per acre in furrow. We tested it on just corn. This year we're going to be testing it on corn and beans, in furrow and 2x2. We're going to see what gives us the best ROI. We're going to pair it with other starter fertilizer packages. What gives us the best ROI when we take it to yield, along with seeing if it changes any nutrient availability within that row in the treated and untreated. So in summary, humic acid is going to increase root development at a faster rate, getting those plants more deeply established. It's going to increase the CEC of the soil, and it's also going to do everything that we want organic matter to do for us, right? So water holding capacity, aeration, drainage, which will lead to just a better overall environment for that seed. A better fed and taken care of plant is going to be a more stress tolerant plant, a healthier plant. So thanks for watching. This is just going to be one other metric I'm going to be looking at coming up here in the 2023 season. If you want to see about any of the other metrics we're going to be tracking, be sure to watch this video right here about water extractable organic carbon. If you like this video, like and subscribe, and I'll see you in the next one.